One of the most common mechanics in old school games like Super Mario Brothers and things like that was something called a scrolling screen. And the basic way it worked was it looked like the character was always in the center of the screen. And as the character ran forward, it looked like the character was running through the level. But in reality, what was happening is the character was standing still while the world ran through it. So that's hard to visualize because we always think of it from the other perspective. But really, what's actually happening is the character is standing still and that background is running by it. So it's all a relative look. How do we actually achieve this in our program? So, because our characters don't actually run through the level. They just stay where they are. They may jump up and down, but horizontally, they don't really move. It's the world around them moving. So we want to achieve the same goal, the scrolling screen effect. The good news is it's pretty much identical to any form of translation. We have some object and we want to move it across the screen at a given speed. That's it. The only difference here is that it's kind of moving in the reverse that we want. So for example, if we're moving to the right, if our character wants to move to the right, in order to give the illusion that the character is moving right, the background must move left. So it just kind of gives the opposite effect there. And that's what we need to do. So what you see here is I've created a couple constants to represent the direction. Now you'll notice that they're a little backwards from what we're used to. So in this case, left is getting the positive one and right is getting the negative one because they have to go in the opposite direction that the character thinks they're moving in. Now I've also created some other standard variables like the screen width and screen height. And the reason why I did this is because we need those values when we're defining our background, just like we would always do when we're doing background images. I haven't really created too much different here. So I have a background image, a texture 2D, and I have a ship image to be our character while we're moving through the world. I have a rectangle for the ship. And then I have a few variables that we normally use for motion when we're using translation. So we have our rectangle for the object that we want to translate, and we have that true position variable for the object that we want to translate. But you'll notice that I have two of them here. And the reason being is the way that we create this effect of a scrolling screen is that we actually have more than one screen there. We actually have more than one background image. So I'm going to show you an example of an image that we're going to use. So this is just a simple background image. And what you can see is that it's actually designed intentionally to end exactly where it starts. So if you lined up two of these images side by side, they'd look like they're exactly one image repeated exactly one after the other. And that's the idea. It's the only way we can achieve this scrolling effect. So the idea that it's an endless world. And that's what we want to do here. So I want you to visualize this. Let's see if I can, I don't know if they'll let me open up a second instance of this image, but we'll see. Ah, perfect. So let's see if we can shrink this down a little bit. Try and get it right beside the other one. There we go. And then we'll shrink this one down too. So what's actually happening is if we line them up the best I can here, what's happening is when we run to the right, our character is going to be standing about right here in the center of this. When we run to the right, both of these background images are going to scroll to the left. And eventually one of them, this one to start with, is going to get all the way off the screen. And when it does, it works like a conveyor belt. It's going to get zipped all the way back to the other side of the screen. And then by that time, this one is already working its way through. So you can see it just creates a conveyor belt, a loop of these two images. And if we start to move the other direction, it just starts going the other way. So all we have to do in terms of logic is detect when one of them gets fully off the screen in either direction. And when that occurs, we quickly bump it back to the other side. And the way we do that is we simply, for example, if it's all the way off on the left, we're going to add two screen widths. Add one, add two. And that's going to put it exactly in the right position. If we're scrolling in the opposite direction and one of our screens gets fully off on the right-hand side, that means we're going to subtract one, subtract two screen widths. Okay, so let's go take a look at the code to see how this actually occurs. So again, we've loaded 2 images for our rectangle and 2 true positions. Here's my other movement variables that we're used to, our speed maximum and our regular speed. Perfect. And you can see I have it moving at a rate of 300 pixels per second, which is a pretty good speed, and you can adjust this as you need to. I got a keyboard state to handle controls moving left and right. Now you could add more controls to it if you want, but this is just a demo. I've loaded or set up my screen width and screen heights as normal. I've loaded all my images, nothing special here. Load the images here, set my rectangles. What you'll notice here is that I'm setting the rectangles for the backgrounds first. So the first one is directly at the top left corner of the screen. The next one starts at exactly the screen width over. So it's literally at the edge. But it's at the exact same height, and it has the same width and height as the other image. So they consume the whole screen. And then the true positions are just a recording of the 2 rectangles. No problem. In terms of updating, what's actually happening? Not a whole lot here. Take a look. I get the keyboard state, and I say if the user hits the left key or the A key, so if they're using arrows or WASD, then I'm going to call this method called scroll screen. And it's going to take the direction that I want to scroll and how much time has passed. Because remember, that's how we handle moving at the proper speed. So the direction and then the time passed. Those are its only 2 parameters. If I choose to go right, then I'm going to say this direction is scroll right. And there's my actual logic there. So now let's go take a look at the scroll screen method. What does it actually do? Drawing is pretty straightforward, just drawing the 3 things. So here's our scroll screen method. The first thing I do is I calculate what my speed per update is. So the direction times the speed maximum times how much time has passed. This is the exact same calculation we did for translation in previous lessons. Nothing different. I've taken that scroll speed and I add that scroll speed to both of the background images, to their true positions. Now, once that I've moved them, I got to check to see whether they went off the screen. So here's me checking if the first background completely left the screen. So that means that its X value is going to be less than or equal to negative screen width. Negative screen width? Yep. So if this is 0, right here at this corner, if it's fully off the screen, that means it's moved off the screen exactly 1 screen width or more. So negative screen width. Great. So if the X value is less than negative screen width, then I'm going to add on to it 2 times the screen width. In the other direction, if it's greater than exactly screen width, which is the right side of the screen, so if its X value is greater than the right side of the screen, well then I'm going to subtract 2 times the screen width. And then I do the exact same thing for the second background, because either one of them could be off. Once I've fully moved the true position, I've set everything the way it should be, then I finally copy it into the rectangle. I don't need to copy it into the rectangle until I know I'm done. Otherwise, it's just wasted effort. So calculate the speed, move the true position, test for collision with the side of the world, and then set the actual draw position. And that is it. Let's go take a look. So I have my little alien in the center of the stage, and now I'm going to hit the D key to move right. And you can see the screen scrolls left, and I can hold this as much as I want. Or I can go the other direction. Now you guys like, how do you know where one starts and where stops? Just to show you so we can see this divide, I'm going to change the draw code to draw the first background image with a red filter on it, and the second one with a blue filter on it. So we should be able to clearly see which background image is which. So there's the basic one, the first one. If I just move to the right a little bit, we can see it pops on the screen. Move to the left, and you can see it's just recycling itself, zipping over to the other side to make it look like it's a very seamless and perfect image. So when you're Googling for images like this, what you want to look for is a scrollable background, and that's how I found this. There's other effects that we can add to this as well. I'll show you an example of something that's a little bit more advanced. Just give me 1 second to pull it up. So this is a demo I did for another one of our engines, but it's just to show you the effect that it can actually happen here. This is actually in the Java game engine I built for the grade 10s. So what you see here is a pretty standard world. It just looks like some clouds, some hills, and then a bush on some grass. But watch what happens when I scroll to the right. Oops. Look at that. Things are moving at different speeds. The clouds are moving the slowest, the mountains are moving at a pretty standard speed, and then the bushes in the front are moving faster. What this does is it creates an illusion of depth. It makes it look like the clouds are far off in the distance, the hills are about where we'd expect, and the bushes are closest to us. Now, if I took the spaceship and put it in between the hill and the bushes, it would give an even better effect in terms of depth. This is what we call parallax scrolling. And it works exactly like regular scrolling, except you're scrolling multiple backgrounds at a time, and each one scrolls at a slightly different speed. Your middle ground, which would be the hills in this case, would be your standard scroll speed. Your clouds would be some slower multiple, so maybe like a multiple of like 0.2 or something. And then the bushes would be a faster multiple, and they would be maybe a multiple of like 1.5 or something like that. And then you would just move everything as you need to. And that's it. That's all there is to it. I'm just didn't recode this in C# because it's not necessary to do so. It's exactly the same as the other stuff. Okay. That's it for scrolling screens. If you have any questions, you know where to find answers. Talk to your teacher, and they'll hopefully be able to answer anything. That's it. Good luck and have fun.